Open your book to page 266. This lesson is on space coordinates. So basically this is deal with a three-dimensional rectangular coordinates. In algebra you deal with two-dimensional, 2Ds, you got X and the Y. Now over here we have the 3D, the three-dimensional. Now in the book they use a different they use a different orientation. They have the X, Y, and Z. But instead of doing it this way, since we're familiar with X and the Y in this direction, we're just going to add one more dimension. So what we're going to do is we're just going to do the X, the Y, and the Z. Again, you have to rotate in the counterclockwise direction, so X, Y, Z direction. And so if you were to plot a point, because it's three-dimensional, if you just plot a point, you're not going to know what the coordinate is. So you need to do a trace. So for example, let's say if you have this kind of graph, so if you want to plot, like if you're going to plot the coordinate 1, 1, 1. So what you need to do, you start over here, and so this is your X, Y, Z, right? So start at the origin, so you go 1 in the X direction, and then you go. So you have to use a ruler to measure. Okay. So each division in this case is 1 centimeter. So this 1, so that X is 1 and go up 1, that's Y. And then Z, you have to go this direction. So from here goes Z. Okay. So in this case, you're going 1, 1, 1. So your point is right over here. Okay. So when you're plotting a three-dimensional point, you need to do the trace. Okay, so that way people can follow. Okay, so this is 1, 1, 1. Because if you just plot a point over there without a trace, then there's no way telling what coordinate is this point. Because this point can be, without a trace, it can be 0, 0. Another possibility is 0, 0, and negative, like 2/3, for example. Okay, so again, without a trace, there's no way of telling what the point is. But using the trace, then it's very easy to follow that this point is 1, 1, 1. Okay, so that's how you plot the three-dimensional point. Now, the three-dimensional equations to figure out the length and midpoints are very similar to what's two-dimensional. So let's go to page 268. So in two-dimensional, you have 2 points. You got point 1, point 2, and so this is point 1. This is point 2. The distance between, so absolute value means distance, right? So absolute value of P1, P2 means the distance between P1 and P2. So this is X1, Y1, and this is your X2, Y2, right? So use your Pythagorean theorem. So two-dimensional, in two-dimensional equation between the distance between 2 points would be X2 minus X1 squared, right? That's your A squared plus B squared, so be Y2 minus Y1 squared, right? So again, this is the distance between the 2 points in two-dimensional. Now in 3D, in the three-dimensional, you got a point 1, point 2, same thing, right? So P1, now because it's three-dimensional, you're going to get X1, Y1, Z1. And the point 2, P2, we get X2, Y2, Z2. So now the distance between the 2 points is exactly the same thing. You just add one more dimension. Okay, so it would be just X2 minus X1 squared plus Y2 minus Y1 squared plus Z2 minus Z1 squared. Okay. So let's do the example 1. So on page 269, example 1, you have the 2 points. So you got P1 is at negative 4, 4, 1. And P2 is at negative 3, 5, negative 4. And you're looking for the distance between the 2 points. So the distance between P1 and P2, again, absolute value means distance. So all you have to just go and figure out usually A squared plus B squared plus C squared equal to the length, right? So you're going to get negative 3 minus negative 4 squared, that's the x, right? Plus the y2 minus y1 squared plus z2 minus z1 squared. And so the distance between the 2 points will equal to, so this will give you negative 3 minus negative 4 give you 1 squared, so it would be 1. This one plus 1, again 1 squared is 1, so this one is negative 5 squared would be 25. And so P1, P2, distance between them is square root of 27, and then you simplify, equal to 3 square root of 3. And there's the length between the 2 points in the 3D. Okay. Now, it's the same thing for, now let's go to the midpoint. So on page 269, the midpoint. So in two-dimensional, again, you got point 1, point 2, and you got x1, y1, you got x2, y2, right? And the midpoint over here, that's the midpoint. So the midpoint, the coordinate would be the average of the two, right? Again, you average to get the middle. So you get x2 plus x1 over 2. That's, you add, divide by 2, that's your average. And then the y, do the same thing, y2 plus y1 over 2, right? That's your, again, midpoint is the average. So this is for two-dimensional. Now, when you are three-dimensional, you do exactly the same thing, right? You got point 1, point 2, and here's your midpoint. And you got x1, y1, z1. Over here, the point 2, so this is your point 1. Point 2, you got x2, y2, z2, right? So the midpoint, the coordinate of the midpoint would be just the average of each one, right? So it would be x2 plus x1 over 2. That's for the x. For the y, you get y2 plus y1 over 2, right? And for the z, you get z2 plus z1 over 2. Again, you can see that it's exactly the same thing. You just add one more dimension. Okay. So in example 2, it says find the coordinate of the midpoint of the segment joined. So you got A is 3, negative 2, 4, and B is negative 6, 5, 8. So the midpoint would be, you can just average the two, so 3 plus negative 6 over 2, negative 2 plus 5 over 2, and 4 plus 8 over 2, right? Again, midpoint is halfway between the two, so that means it's the average. So the coordinate for midpoint would be negative 3 over 2, and it'd be 3 over 2, and 12 over 2 will give you 6, and that's it. Okay. Okay, now let's go to example 3. Example 3 is as found the coordinate of the point P, which is 1/3 of the way from A to B. So that's what it is. So point A is 1, 3, 5. Point B is 5, 7, 9. And you're looking for point P that is 1/3 of the way. Okay, so here's point P. And you're looking for X, Y, and the Z. Okay, so this is 1/3. So that means this is 1, and this is 3, right? 1/3 of the way. Okay, so I'm going to do the X first. So for X, first you need to go ahead. So what you do is the formula is the same as the one from before. So first you subtract, so you get 5 minus 1. So 5 minus 1, that's the whole thing, right? That's the whole length for, again, I'm just doing with the x, right? So x is going to be equal to, so 5 minus 1, give you the whole length, and then you times by 1/3 to get that. Okay, so again, so this is the whole length, times 1/3 is this over here, okay? And then you have to plus your starting. You're starting with 1, right? So you start over here, you add this length, that's how you get the x. Right? Again, 5 minus 1, 5 minus 1 to get this length. You times by 1/3, that's what you want. So this is the length over here. But to get this coordinate, you have to start with 1, right? That's what your starting point. So starting point, you add this length, right? Starting point, add this length, that's how you get that. Okay. So x will be equal to 1 plus 1/3 times 4. So x equal to 1 plus 4/3. So x equal to 7/3. And I would prefer that you use fraction. Now you do the same thing with y, right? So y, again, so when you draw this, right, just draw it horizontally, that's fine. So first you start with 7 minus 3. So 7 minus 3 is this whole length. You times by 1/3 to get this length. And you have to add what you start out with, right? So you start at 3. So you start at 3 and you add this length, that's how you get to the y. Okay? So y equal to 3 plus 1/3 times 4. So y equal to 3 plus 4/3. So y equal to 13/3. Okay, now you do the same thing with z, right? So you get 9 minus 5. So 9 minus 5 give you this length. You times by 1/3. And then you have to plus what you start with. You start with 5, right? So you start with 5, and you start with 5, and you have to add the length to get to the next coordinate, right? So z equal to 5 plus 1/3 times 4. So z equal to 5 plus 4/3. So z equal to 19/3. So your point P would be at 7/3, 13/3, and 19/3. Again, you're looking for coordinate, so you have to put it in the parentheses, put in this form. Okay, let's go to example 4. It says giving A at 1, 4, 7 and B is 5, -1, 11. And you're looking for P such that the ratio of A, so you have AP to PB is equal to 4 to 7. Okay. That means from A to P is 4, P to B is 7. Okay, so here's a point P. So AP is 4 and PB is 7. That means this whole thing is equal to 11. So you got to watch for this, right? Okay, so you got to figure out the total length. So you can solve for X. It's going to be 5 minus 1, right? So 5 minus 1 give you the whole length. Then you have to times this fraction. Now it's not 4/7, it's 4/11. So you have to times 4/11, right? It's 4 out of 11. Then you have to plus your starting point, which is 1. Right? So again, this is just the distance. So you start at 1, you add this distance, that's how you get the x. Okay. So x equal to 1 plus 4/11 times 4. X equal to 1 plus 16/11. X equal to 27/11. So you do the same thing with the y. Again, you start with this over here. So you got -1 minus 4. -1 minus 4 give you this whole length. Then you have to times by 4 out of 11, by 4 out of 11 to get this length. Okay, and you have to start out, you have to add what you start out with. So you start at 4, right? You start out at 4 and you add this length. That's how you get to this point, right? Again, you start with 4, you add this length to get to this point. So y equal to 4 plus 4/11 times -5. Y equal to 4 plus negative 20 over 11. So y equal to 24 over 11. Okay. And then you do same thing with z. So again, you use 11 minus, right, that's your z2 minus z1, right? 11 minus 7, that's the whole length. Then you times it by 4 out of 11, not 4 over 7. Again, so you have to be careful with this, right? So 4 out of 11, that is this length. Then you have to add whatever you start out with. Right? You start at 7, you start with 7, you add this length, that's how you get to that coordinate, right? Okay, so just work out the math. Again, do it step by step. Okay, remember math is communicating, right? So don't just write down your answer. Okay, and then after that, so the point P, we have a coordinate of 27 over 11, 24 over 11, 93 over 11. Again, you're looking for the coordinate, so coordinate you have to put in it. So this is the coordinate triple.